Oh, I see.
Roll sheet, make it around somewhere. Roll sheet is where. Wow. Oh, tomorrow. Tomorrow, 1 M or 2 R, is that right? No. 2 M's, 1 R, what's tomorrow? Is that right? We spell check all the time. But. All right, we're gonna get started here. I'm assuming that 11 is from the formulas of compounds quiz, so here we go. 11, manganese 2, hexacyanoferrate 2, so manganese 2, Mn plus 2, hexacyanoferrate is Fe, left parentheses, Cn, right parentheses 6. That is actually a -4 charge. Why is that a -4 charge? It's actually telling you what the iron is in it. So it's kind of a freak that it gives you a Roman numeral on the negative, but it's actually telling you what iron is in there, but it doesn't matter. The whole thing is -4, so we're going to need another manganese, right? And that should do it for number 11. 14. 14 down below, find the oxidation state of the underlying ion in AlMnO5. All right, so we have Al, we have Mn, we have 1, 2, 3, 4, 5 oxides. All those oxides. -2, -2, -2, -2, -2. Aluminum always, always, always is +3. If we got to get 0 out of that, what's my manganese? Well, this is total of plus or minus 10. So I got to get a +10 total, so my manganese has to be a it's going to give me my +10, right? +10 and -10. Okay, 14. Oh, I've got them highlighted here. 14. 31. Let's do 31. Okay. 31, which of the following compounds is written correctly? You have to go through and just hammer out every one. So I'm going to take A. I've got BOOO. Remember, you got to assume you know the negative. And this is oxide, -2, -2, -2. That means that boron would have to be a +6, right? Is there a +6 boron? No, 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 no. That's junk. There is no such thing as a boron 6. So we go to the next one. We've got W. CO3, CO3, CO3. We've got 3 carbonates. What is the oxidation state of carbonate? -2, -2, -2. That means we're looking possibly at a tungsten 6. Is there a tungsten 6? Yes, tungsten 6. Okay, so it looks like this looks pretty good. Let's keep going though, just to make sure, because there is a tungsten 6. In letter C, we would have LiClCl. This would have to be chloride, -1, -1. That would make lithium +2. And that is absolute junk because lithium is always, always, always +1. All right, so C for sure is garbage. D, what do we get here for D? We have Zn, and I could write it like this, ZnS. There's 2 ways to look at this. Well, we always stick with the negative. We know that this has to be sulfide, so that's -2, which means my zincs would have to be +1 and +1. And zinc is always, always, always +2, so that is junk. Letter E, CaO3. Let's take a shortcut a little bit. That would give us -6, right? 3 oxides would give us -6. We'd be looking at a +6 calcium, and that's just junk because calcium is only +2. So you really got to look at all of them. Once you get one that looks good, make sure the other 4 are junk, huh? All right, so in the next one, we're going to start in reverse order. Let's go with E. So if we do E right here, and NO4, we'd be looking at what on the nitrogen? Looking at a +8 here, correct? 4 oxides at -2 gives us -8. We'd be looking at a +8 nitrogen, and that is junk, not possible. In letter D, we're looking at lithium sulfide. Sulfide is -2. The only negative charge sulfide can be a -2. That would leave me with a lithium +2. And that doesn't work because lithium is always +1. Letter C. I'll put C right here. We have CuOO. -2, -2. +4. Junk, why? Copper's got a BA. Looking copper B. Two or 1, right? Well, however, what if this O2 was peroxide? If that is peroxide, you really have this. You have CuOO. Remember, peroxides are -1 each, so it's -2. +2. That's good, right? Copper 2 peroxide would work, which is going to make the rest of these other ones junk here. And those can be kind of ugly, so we're going to stop right there. Because we don't have parentheses. A and B are kind of ugly to figure out, but if you have parentheses, like this is cyanide, this is nitrite, this is sulfide, This PO4 right here should be a phosphate. So that's how those work. 35. Somebody wants to do 35. Let's do that. So in A, well, we'll do it in reverse order again. If you have CO3, you assume this is oxide, that would give you a +6 carbon, right? And there's no +6 carbon, so that's garbage. Letter D. In letter D, we would have chromium with 3 carbonates. And what is the charge of carbonate? -2, -2, -2, right? So this gives us a chromium +6. Is there a chromium 6? Chromium 6? Chromium 6? Chromium 236. There's a +6 chromium. That looks good. Chromium 6 exists. Letter C. We do C. We've got yttrium sulfate. We've got yttrium sulfate. Oh, let's see. I don't think this works writing it out like this. -2, -2, -2, -2. Yttrium is always +3. That'd get us a sulfur 5. And there is no sulfur 5. So that makes that junk. Letter B, we would have nitrogen nitrate. Oh. Let's do it this way. This for sure is nitrate, which is a -1. You have 6 of them. That gives you -6. So the nitrogen would have to be a +6. And there's no nitrogen 6. In letter A, you have HHCl. And the Cl is -1, always as a negative charge, +1/2 and +1/2, right? Which makes that jump. All right, 35. Let's see, I think we got 3940, 3940, 3940, 3940. All right, 39. We've got magnesium +2, aluminum +3. Those are locked in. That's the only positive charge they can be. And my negative is sulfate, which is -2. Well, I've got a +5 so far and a -2. Let's put a -2 in there again. I've got a +5 now and a -4. Let's put another sulfate in there. A -6 and a +5. Now I'm looking to add magnesiums or aluminum, whatever's going to work. So I can't get a +6. Let's put another sulfate in there. That gives me -8. Can I get a +8? Can I get a positive 8? Sure, if I have another aluminum, right? So it looks like I've got 1 magnesium, 2 aluminums, and 1, 2, 3, 4 sulfates. Would work. That would work. Okay. So we'd have MgAl2SO4, right? That's the best we could do. Okay, 40, we've got tin 4, manganese 7 citrate. Whoa. Sn plus 4. Manganese plus 7. Citrate. C6H5O7. And my citrate is -3. Oh, instead of writing out all those citrates, let's do this. We've got a +11, a -3. For sure, we got to put parentheses around there. And we've got to crank this number up right here. Right? There's going to be a number here. We're going to need more than 1 citrate. So if I put a 2, that gives me -6. Well, I got to get above +11, correct? I got to get above +11. If I put a 4 in here, that gives me -12. That won't work. If I put a 5 in here, will that work? The 5 gives me negative what total? -15, right? Can I get a positive 15? I can correctly. I just need 2 of these, right? Because that'll give me +8, +7. That's a +15 and a -15, right? That looks good. That looks good. All right. So that's the way to look at those. There's a way to figure them out. What are you trying to do? You're trying to get 0. Okay, so this is due tomorrow night, which would be 2/16. 2023, 11:59 p.m. I believe, or is that 11:55? 55 or 59? I don't know. So you're just going to enter the answers. They're going to be in a different order. They could be in a different order. They should be the same questions. All right, let's close the book on this quiz. We're going to continue with the mole. Now, yesterday, so we're on page 12. This is where we left off. Okay, I want to try to uncomplicate this for you again. This was my example yesterday, Monday. If we had a chart like this, that was the mass of eggs. And we have all different size eggs. We know that. I picked out a hummingbird as a small egg up to an ostrich and everything in between, correct? If we had this number, let's see, this is my robin egg, 9.012182, whatever grams. This would be the mass of 1 egg. Or if I have a dozen, it would be what it is for a dozen, correct? This is my mass for one atom in AMU. But if I have a mole, it's this number in grams. And every time I have a mole, how many? 6.022 times 10 to the 23rd. Right? And again, it's just a pain in the butt number. It's a huge number. You'd have to move that decimal point 23 places to the right. It's just a humongous number. But it's just a number that means a mole. It's like 12 means a dozen, correct? So it sounds complicated. It's not any more complicated than 1 dozen is 12. So here's where we left off. We said, what is the molar mass of ibuprofen? C13H18O2. And we did the algebraic sum from the periodic table. We have 13 carbons at 12.01 AMU for an individual carbon atom. We have 18 hydrogens at 1.01. And we have 2 oxygens at 16, gets us 206.31 AMU for a single molecule. But if we have a mole, it's this many in grams. This is for 1 mole. This is for 6.022 times 10 to the 23rd molecules. Anytime we use grams, we have a mole. And every time we have a mole, how many units do we have? 6.022 times 10 to the 23rd. So if we do the next one, this is aluminum sulfite. So let's see what we can do. Algebraic sum. We've got 2 aluminums. And if we look up aluminum on our periodic table, 26.98. Plus, how many sulfur? This would give us 3 sulfurs, right? 3 sulfurs because we have 3 sulfites. We have SO3 3 times. 3 sulfurs. $32.065. So if we do 2 decimal places, we'll do 32.07. We're doing 2 decimal places. Plus, how many oxygen? 9 oxygen. Now your calculator will do it as you see it without parentheses. Your calculator will do 2 times 26.98 plus 3 times 32.07 plus 9 times 16. It'll do it just as you see it. That would give you 294.17 AMU for 1 formula unit. But we want the molar mass, so it would be 294.17 grams. And how many formula units would I have? 1 mole, 6.022 times 10 to the 23rd. Okay. Let's go right here. There are two conversions. Let's use this spot right here because we've got enough room to go just like this. There are two conversions we're going to use. One mole. It could be an atom. We could use molecule, or it could be an ionic compound. Oops. Equals grams. How are we going to figure out the grams? We're going to be using the periodic table. But we could be talking about a mole of atoms. That mole might be helium. We could be talking about a mole of molecules, a mole of water. An ionic compound just starts with a metal. This could be a mole of salt, sodium chloride. But it's the same thing. You're just going to have to add everything up on your periodic table. It's the same thing, but realize you might be describing an atom. So I guess I can actually put an example in there. 1 mole of helium it could be. We have a molecule, water. An ionic compound, NaCl. It doesn't matter, it's the same. And the other thing is 1 mole, we keep the E off of all of these again, 1 mole of atoms, molecules, or ionic compounds. 1 mole of whatever is equal to 6.022 times 10 to the 23rd units. We could be talking atoms, molecules, or ionic compounds. Or 1 mole of pigs. Which 1 mole of pigs would probably cover the earth a mile deep. I don't know. It'd be. Okay. So now we're going to do some examples. Please, 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 when you go do your OWL, I've got this laid out. We are going to start with grams. We are going to start with grams. I'm putting this underneath it so it doesn't bleed through. We're going to start with grams, and we're going to end up trying to find moles. Here, we're going to start with atoms to find moles, and so on. Here, we're going to start with grams, and we're going to end up finding atoms. So when you're looking at OWL or the quiz, please come back and look at this. This is why we're doing it, right? You should be able to find some, hey, how many moles are in so many grams? You'll be looking at this example. Okay, so we've got 4.7 grams of potassium. How many moles of potassium do I have? All I'm going to do is do my conversion from the periodic table. Grams of potassium in 1 mole of potassium. If I start with grams, I got to put grams down there. And that grams from our periodic table to 2 decimal places. 2 decimal places, 39.10. 39.10. Grams cancel out, and I'm going to get more, right? So if I divide that out, and if I do it to 2 sig figs, because I'm starting with 2 sig figs, I would get 0.12 mole of potassium. Remember, there's only going to be 2 conversions we're going to use. 1 mole to grams or 1 mole to 6.022 times 10 to the 23rd. The next one starts out at atoms. It has atoms and we want moles. We've got 9.2 times 10 to the 24 atoms. Ooh, I made a bad mistake. 1 mole of argon. There's 2 things you always know in chemistry. Number 1, that I say all the time, never trust an electron. Number 2, if you're given a problem and you're not given moles, first thing you should try to do is find moles. If you're not given moles, how do you get the moles? First step should be, how do I get the moles? Because we got to do everything in moles. How many atoms are in a mole? 6.022 times 10 to the 23rd, right? So 6.022 times 10 to the 23rd. Got it. My atoms cross out. And I'm going to get now remember, don't put in times 10. Right? Do not put in times 10. So 9.2 EE or EXP 24 divided by 6.022 EE or EXP 23. It equals, and we should get 4. No, not 0.037 grams. No. Yeah, what do we get for this? I changed the problem here. I better punch the dang thing in. I changed the problem previously. 9.2 to the 24 divided by 6.022 to the 23. I got 15. I got 15. Yes, 15 if we round this up. $15 moles? Yes? All right. All right. So we've got, now we went atoms to moles. Now we're going to be given grams, but we want atoms. So we're going to start out here at 5.00 grams of copper. What's the very first thing you should do? Yes. Why that round? Which one? This one? Isn't that 39.09? It's 39. It's 39.0983. So if I round this to 2 decimal places, This 8 would increase this 9. So then we get 39.10. Oh, because I mean you could, but they're all different. Like if you take phosphorus, then you're going to stick all those in there. So this has 5 decimal places, but this one only has 3 decimal places, but this one has 6 decimal places. This has 3, this has 4. It's more that way. Some students are going to cut it off. If we're all doing the same thing, the 2 decimal places, then everybody can compare answers. It kind of works out good. So 2 decimal places works. The only time you get into a problem sometimes is rounding off. We're rounding hydrogen off, but 2 decimal places pretty much does it. So we're going to do 2 decimal places on copper. Copper is right here. So if we do 2 decimal places on copper, we're going to do 63.55, right? So here we've got remember, convert the moles and see if you're done. 63.55 grams of copper, and now I'm going to close this up. Always convert to moles, and hopefully that's all you need to do, but in this case, we need atoms. My grams are going to cancel out. What am I going to do? I'm going to add another step. I've got 1 mole of copper, but I know 1 mole of copper is 6.022 times 10 to the 23rd copper atoms as well. You could take a little bit of a shortcut here and cross out the 1 mole and put in 6.022 times 10 to the 23rd. But this is using both steps, right? There's only 2 things we do. 1 mole to grams and 1 mole to 6.022 times 10 to the 23rd. So mole here cancels out, and I'm going to be left with copper atoms. And starting out with 3 sig figs, I got 4 and 4. So if I finish this with 3 sig figs, (4.74 times 10 to the 22 copper atoms. Now notice up here, we haven't done any molecules or formula units, correct? Just atoms. We've used the term atoms, atoms, atoms. But glycine, we would use the term molecules. This is molecules, it's full of nonmetals. Molecules, molecules. All right, let's see what we've got. We've got 28.35 grams of glycine, which is C2H5O2N2 moles. So we're going to start out with 28.35 grams of C2H5O2N. We're given grams, we just need to find moles. This has to be grams of C2H5O2N. Carbon. What is it from the periodic table rounded to 2 decimal places? Carbon. 12.01. Hydrogen. 1.01. Oxygen. 16. Nitrogen is 14.01. You'll start memorizing those. So we need to do the algebraic sum. 2 times 12.01 plus 5 times 1.01 plus 2 times 16 plus 1 nitrogen. Grab your calculator, throw those pigs in. Grab your calculator. We get 75.07. Okay, so now if we divide that out, we know we're going to get a number less than 1. And if we divide that out, we are going to get 0.3776 mole of C2H5O2N. Okay, vitamin C, we would call this molecules. It's made up of non-metal atoms, so the compound vitamin C, we'd refer to it as molecules. We want to know, we have moles, we want to know grams. And I'm going to take this out of scientific notation, and I'm going to go 0.000142 mole of C6H8O6. And I'm going to grams. I'm starting out with moles. So I have to put 1 mole down here of C6H8O6. And then how many grams? Again, 12.01, 1.01, 16. Grab your calculator, 6 carbons, 8 hydrogens, 6 oxygen. What do we get? $176.14. Yes, vertical nods. All right, we got some vertical nods out of that. Notice, ooh, I didn't cancel my units up here. My grams there are going to cross out. My moles there are going to cross out. I want grams moles to grams. Okay, so I'm done. I start out with 3 sig figs. I got 5 sig figs. We're going to do 3 sig figs, and we're going to get 0.0250 grams to 3 sig figs, and that's grams of C6H8O6. All right. This looks a little bit ugly. You want to know, you've got 40 milligrams of saccharin. You want to know how many atoms of carbon. We only want atoms of carbon, and we know at the end, every time we have one molecule, we've got 7 carbon atoms. We're going to have to use that at the end. And we're going to need all the room we can get. So we are going all the way to the left here. We're going to start out with 40 milligrams. We're going clear over, let's see. We're going to start right here, way over here. I'm going to convert that to grams. We're going to start with 0.0400 grams of C7H5NO3S. And the very first thing we need to do, no matter what, if you haven't got moles, find moles. This is going to be 1 mole C7H5NO3S. Grams C7H5NO3S. Twelve point oh one, 1.01, 14.01, 16, and 32.07 is what you'd get looking on your periodic table, the 2 decimal places. So C7H5NO3S gets us 183.20 grams. Yes. Nope. Just O times 3. There's only 1 nitrogen. Yep. Okay, then we're going to go 1 mole of C7H5NO3S is going to be 6.022 times 10 to the 23rd molecules. C7H5NO3S. Then, every time you have 1 molecule of C7H5NO3S, it has 7 carbon atoms. And finally, we end up with carbon atoms. Everything will cancel out. And we get 9.20 times 10 to the 20th carbon atoms. That will get you poking around in OWL for sure. That means you can get through 1 through 21 on this quiz now. 1 through 21. 1 through 21 in that quiz. And then we'll see you Friday. Stay out of trouble between now and Friday. Don't smoke, vape, or get COVID.